Hi, this is Thomas from AP's Game Tools. In this video we're going to look at clearance, which means support for differently sized units. The first part of the video I'm going to show you how to set up clearance, and in the second part we're going to look at the different limitations to this implementation of clearance. Now, to set up clearance we have 3 steps, one of which is optional. The first step is to ensure that all your different units have an appropriate radius set. On the unit component we have the radius property. You just need to set that to the value that represents the unit's actual radius. The second step is on the game world. On the navigation settings component we have a use clearance. This is the new property. If you check that, then you will be using clearance. This also has a second property that has to do with height differences in a grid with height sampling enabled, such as this with height sampling set to height map. The third step, which is optional, we'll just get back to when we do the demo. Now, just to understand what clearance means, clearance is basically for any given cell, its clearance value represents its distance to the nearest obstacle. There are 2 forms of obstacles, static obstacles like these, and height obstacles like this one down here. Now, this second setting has to do with height obstacles. What it means is that if the height difference between a cell and its neighbor is larger than this value, then that neighbor will be seen as an obstacle, which means that the clearance value of this cell will be the same as if this had been a static obstacle. Now, there are 2 scenarios in which you want to use clearance. The first is if you have differently sized units and these units do not fit in, or the largest of these units do not fit in to one cell. And the second scenario would be if you, for some reason, you want your grid's cell size to be smaller than the unit, even if you don't only have one size unit. If the unit cannot fit into a cell, then you will want to use clearance. So that's basically it for the setup. We'll now look at a small demo, and I'll also show you this third setup option. When I start my scene, as you can see, the different cells are now annotated with their clearance value. This annotation is done by this visualizer that you can also add to your scene if you want to see these numbers. Our unit, as we saw, is 1.5 wide. Sorry, it has a radius of 1.5, so it will be able to move through all the different cells that have a clearance value larger than that radius. So if I put it over here, as you can see, it will then choose to move through cells that have, in this case, a clearance of 3, but it will not be able to move through cells with a clearance of 1. Now, this leads us to the third setup option. If I give my unit a destination that is actually in a cell that has insufficient clearance, the default behavior of the Pathfinder would be to tell me that I cannot move there because the cell does not have enough clearance. To overcome that, we have introduced a new feature called request preprocessors, and in particular for this, for clearance, we have included this preprocessor called the ensure destination clearance. So the third step, recommended step, is to also add this to your game world, because what it will do is that it will ensure that the destination, or rather it will pick a destination as close to the original destination with enough clearance. So when I give my unit the order to move up here, what it will do instead is that it will actually move as close as it can while still maintaining proper clearance. So that's basically all there is to the setup of clearance. Next we'll be looking at the different limitations to this implementation. The first limitation is visible down here, also on the back side of this obstacle up here. As you can see, we have clearance values on these two adjacent cells of 1, but in reality the distance between this obstacle over here and this obstacle over here is actually 4. We actually have 2 cells in between, so in theory this unit would actually be able to pass through here. But in practice it cannot, simply because the pathfinder moves from cell center to cell center, and it cannot move from any cell center to any other cell center in between here with the required clearance. So in practice it cannot move through here. There are a few options obviously to overcome this limitation. One would be to ensure that the geometry is placed in a way that this does not occur. So for instance, if I moved this obstacle here 1 cell to the right, I would have 1 cell in the middle that would have enough clearance for my unit to move through here. Another option would be to change the setup of the grid so that I have smaller cells in my grid. So let's try and do that. I reduce my cell size to half of what it was, back to 1. Now when I start, as you can see, now I have more cells in between these 2 obstacles, and 2 of these cells actually have enough clearance for my unit to pass through here, so now I will actually be able to get a path through here. The downside to this last approach is that when you do reduce the cell size, you get more cells obviously, and the more cells you get, the longer it will take for the pathfinder to actually find a path from A to B. So just consider that when you try to solve this limitation, you shouldn't have too low a cell size because it will heavily impact the pathfinding. So let's reset it back to what it was. The second limitation has to do with height differences. As I just explained before, an obstacle with a height difference, a height difference in the terrain will be considered an obstacle by the clearance if it goes beyond the threshold set on the game world. Now this has another consequence. As you can see, we have here a platform. The unit can easily move up onto this platform, but it will not be able to jump down from the platform onto this cell down here, simply because these cells down here see this platform up here as an obstacle, and hence the unit will not be able to move through this cell. Now this actually works against the height navigation settings of the unit, because this unit is actually capable of jumping down from heights this high, but it will not be allowed to do so because of the clearance value. So in these scenarios you will have to resort to using portals. If you place a portal here and you place a portal down here, one-way portal from here to here, then the unit will be able to move from up here to down there. It will simply move using the portals instead of using its height navigation and clearance settings. You obviously need to include cells that have proper clearance in the portal down here. If you just set the portal on the 1 cells, it would obviously not work. So that was the second limitation. The third and fourth limitation has they have to do with dynamic updates. There are two forms of dynamic updates. One is runtime updates of the grid. You would do that if you have static obstacles and you remove them or you add some, and then you want to update that part of the grid at runtime. This particular feature, how to do that, is covered in another video. We'll go into more detail on that. But the limitation, or the consequence rather, of doing dynamic updates is that we have to actually recalculate the clearance for the entire grid. So this is just something to be aware of, that if you have or are using this feature of dynamic updates on the grid, then you just need to be aware that it will also recalculate the clearance for the entire grid and not just for the section. Let's say I was just to remove this part of this static obstacle. I would ask the grid to update this part, but it would actually have to recalculate the clearance of the entire grid, because clearance is not just confined to this little space, it actually propagates out from here and potentially to the whole grid. And in effect, it is actually faster to just update the entire grid. It doesn't take a lot of time. It is pretty fast, but obviously the larger the grid, the longer it takes. So just be aware of this if you have loads of these runtime updates. Similarly, we have dynamic obstacles. Since we actually have to update the entire grid in order to set clearance when a cell is changed from being blocked to not being blocked, or vice versa, we've simply chosen not to support dynamic obstacles for clearance at all. So if I have a dynamic obstacle and I enable it in my scene, as you can see, it does not affect the clearance values of the cells at all. My unit will still obviously be given a path around the obstacle, but it will not reflect the correct clearance values. So as you saw, it bumped into the obstacle. This is only a problem in cases where your obstacle is like this in the middle of nowhere. In cases where you have doors, which is the most common use case that you use dynamic obstacles for, things such as doors or to block off different alleyways and such, then this is not a problem. It is only a problem when you have them in the middle here, when you actually want it to affect clearance. It will not. So that is just a limitation that you need to know about. So if you have loads of dynamic obstacles like these in the scene, then you will not be able to use clearance. So that's all there is to say about clearance. See you in the next video.